Okay, so simplifying like terms, also combining like terms. Part of the reason we use algebra tiles is sometimes it's easier to see than it is with the algebraic expression.
I'm dying.
So as we're looking at what does this mean with algebra tiles, we've got 3 solid x's and 5 negative x's, and then 2 solid ones here and another 7 solid ones there. Every time you have a positive and negative, what's going to happen? They're going to cancel each other out. So does it make sense that this positive x will cancel out with this negative x, this positive x would cancel out with this one, this positive x would cancel out with that one? And we're left with negative 2x and just 9. Okay? Now, the goal is eventually just to go from this to this. That's our goal. We want to just look at the algebra and be able to simplify it by combining like terms. So we need to be able to see that the 3x and the minus 5x are like terms, and those can be put together. And we need to be able to see that the 2 and the 7 are like terms, and you can put them together. The algebra tiles help you see that better, right?
Yes.
Because they're actual objects, and you can see which ones are alike and which ones are different.
Wait, couldn't you make those squares like movable?
We say that an expression is simplified once there's no more like terms. So we started off with 3x minus 5x and 2 plus 7. Since those are like terms, we can just write minus 2x and 9. And so our simplified expression is minus 2x plus 9. So here, ask yourself, could you simplify this without algebra tiles? Or would you need the algebra tiles to do it? Can you see the like terms without making the algebra tiles? Or do you need to draw it out to help you see what you need to put together? So try it if you can without, and we'll also show what it looks like if we have it together. Okay, how did you do?
Hey, wait, I'm not done.
Did you get 6x squared plus 7x?
No. I actually did not because I put like 7x plus.
Yeah, and if you wrote 7x plus 6x squared, we generally try to write them in descending order by degree. So the biggest degree here is the x squared. But it's not wrong if you wrote 7x plus 6x squared. Now, with algebra tiles, you would have 1, 2, 3, 4, 5 of them here, plus 2, 1, 2, plus 6x squareds, 1, 2, 3, 4, 5, 6. So can you see why it's kind of nice if you don't have to draw them? If you can see that these ones are the same, 5x plus 2x makes 7x, and these ones are different, so we'd still have 6x squared.
Which guy are you trying to talk?
So are these two like terms? We don't have tiles for these. We could make up new tiles for these. The order of the variables doesn't matter, so normally we like to write them alphabetically. And when we write them alphabetically, we really can see that these are like terms. If you had 5ab and you subtracted 8ab, how many ab's would you have? You would have negative 3. So 5 ABs minus 8 ABs would give you negative 3 ABs.
I'm still alive,
Try this one on your own. Once you think you have the answer, you can volunteer to put it up.
A degree is 3 though, because that's the biggest one out of it, right? Something like that, or right? Is that right?
Yeah, he's gonna race me.
So we have 1y plus 1y plus 1y plus 3y. How many y's do you have? 6 y's. Here's our next one.
You will.
So these are all like terms. If you drew it out with algae tiles, you could have 7 solid ones, then 5 clear ones, and then another 2 solid ones. Or sorry, another 1 solid one, and you'd be left with 3x. Here's the next one. You ready?
Got it.
No, hey, sit down.
Well, we did this one already. We did this one already too. There we go. So how do we come up with this answer? We need to know. Quiet, guys. Quiet.
Did you just call him a squarehead? He had a squarehead. For real. What?
Quiet, please. So one thing that you're going to find helpful, and sometimes people like to use different colored pens for this, is to look and say what things are alike. Can you see that the 2b and the minus 5b are alike? And if you have 2b and you subtract 5b, you're going to be left with negative 3b. The negative 3 and the 1 are alike. What's negative 3 plus 1? Again, you're going to have to think maybe of your number line. If I'm at negative 3 and I go 1 in this direction, because I'm adding 1, I'm going to be at negative 2. And so our final answer is going to be negative 3b plus a negative 2, but adding a negative can be the same as negative 3b minus 2. So first of all, negative 3y and y are like terms. If you have negative 3, if you have negative 3 and you add 1, you'll get negative 2. The other like terms are the 6x and the negative x. So you can either think of it as negative 1 plus 6 to get plus 5, or you can think of 6 minus 1. You can do it either way. Negative 1 plus 6 or 6 minus 1.
No, I don't want to. No, no. I just said I don't want to go alone. Yeah, but I was walking. No! No!
This one's more difficult because you're going to want to do something, but the answer is exactly the same, because they're not like terms unless the variables and the exponents are the same. So this one is a 4x squared, but this one is an x cubed. And an x squared and an x cubed are like apples and chocolate bars. You have 1 chocolate bar plus 1 apple, that doesn't give you 1 apple bar, or whatever that would be. An chocolate bar. Here's the next one. That is correct. You'll get negative 6x squared y plus 3xy. Because this one and this one are alike. And once they're alike, you just have to think about the coefficients. Right? The coefficients are minus 2 and minus 4. And that makes minus 6. The other one, I'll underline a different color because it's not alike with the first two. We can find the perimeter by adding up all the sides. So if I added up all the sides, what would I get? Well, it would look like this. One side is x plus 10. And then I would have to add the 8x minus 3 side. And then I would have to add the 5x plus 1 side. And then I would have to add the x minus 6 side. What does that equal to? Because right now, That's not simplified.
So you go clockwise around always?
Doesn't matter which way.
Doesn't?
No, you could add them up in any order.
They don't have to be disordered.
How many x's are there going to be once you add it all up?
Wait, I'm doing it. Just calm down.
So that is a simplified expression for the perimeter.
Yeah, really.
There's one more for you to try on your own. Are you ready for it? Here's the last one. Find a simplified expression for the perimeter of this one.